Greetings, fine individuals. Welcome once again to the Dr. Zeero Free Magic Secret Show, where we look upon all kinds of magic in many different forms and comment on all kinds of little avenues that most people look beyond. And in a separate video, we talked about the Tao and the viewpoint of Chinese magic and Oriental mysticism. And although they don't necessarily call it magic, it's the same basic function. And to interject this real quick, when you look at the yin-yang, this is the basis of everything. They say, as above, so below, everything generating from two polar opposites, I guess. And they kind of make the chicken and the egg and one all in the same, sort of, kind of. When you look at the Tree of Life diagram, both the cliff off and the Tree of Life, it'd be like if you grabbed a yin-yang and then stretched it like an accordion, and then it revealed itself to be four different yin-yangs in two different directions. So it's kind of like two cubes stacked on top of each other, hence the number 8, the infinity going around in circles. So the point is that when you look at the Kabbalah Tree of Life, what it really is, it's like four yin-yangs on top of each other. And those are all summarized in the Sephirot, the bubbles of the Tree of Life. And those are all like hard set polarities. I wouldn't say static because they're a constant principle of change, but they're fixed, I guess, fixed in their polar extremes. And then the tarot trumps, the lines connecting the paths between the bubbles, these are the animating principle behind all of it. So when you talk about Taoism, we look at, the yin-yang and what would essentially be like the four prime yin-yangs of the Tree of Life, which would be symbolized by the term YHVH. If you're curious how that all works out, when you look at the Tree of Life, the first one is the ace, the Keter, right? Number 2 is Hokman, that's the top of the male principle. That's the first Y. The second H is the top of the female principle, where Saturn's at. The V would be the sun, where like all of it harmonizes. And then the H would be Malkut, the kingdom, Earth, the final one, where it all coagulates. And this is where we get the idea of king, queen, knight, and page. Or king, queen, prince, and princess. It's different decks. So it's these four things. So again, getting back. So the Taoists kind of compact all this info into the simple glyph of the yin-yang, and then you can go into hexagrams and such to decode it further. But so the idea is the yin-yang itself, it shows the polar opposites. So what is the animating principle? Because you can't just rely on, opposites. You have to know more than that. And they do have a clear-cut understanding of this. So this episode is going to revolve around the yin-yang going from just the primal powers fixed in as polar extremes into actual action. So this part of it is sort of like how the trumps, again, animate the Tree of Life. This line of thought and perception animates the yin-yang. When the Eastern mystics tell us that they experience all things and events as manifestations of a basic oneness, this does not mean that they pronounce all things to be equal. They recognize the individuality of things, but at the same time, they are aware that all differences and contrasts are relative within an all-embracing unity. Since in our normal state of consciousness, this unity of all contrasts, and especially the unity of opposites, is extremely hard to accept. It constitutes one of the most puzzling features of Eastern philosophy. It is, however, an insight which lies at the very root of the Eastern worldview. Opposites are abstract concepts belonging to the realm of thought, and as such, they are relative. By the very act of focusing our attention on any one concept, we create its opposite. As Lao Tzu says, when all in the world understands beauty to be beautiful, then ugliness exists. When all understand goodness to be good, then evil exists. Mystics transcend this realm of intellectual concepts, and in transcending it, they become aware of the relativity and polar relationship of all opposites. They realize that good and bad, pleasure and pain, life and death are not absolute experiences belonging to different categories, but are merely two sides of the same reality, extreme parts of a single whole. The awareness that all opposites are polar, and thus a unity, is seen as one of the highest aims of man in the spiritual traditions of the East. Quote, "Be in truth eternal beyond earthly opposites," is Krishna's advice in the Bhagavad Gita, and the same advice is given to the followers of Buddhism. Thus, D.T. Suzuki writes, "The fundamental idea of Buddhism is to pass beyond the world of opposites, a world built up by intellectual distinctions and emotional defilements, and to realize the spiritual world of non-distinction, which involves achieving an absolute point of view." The whole of Buddhist teaching, and in fact the whole of Eastern mysticism, revolves about this absolute point of view, which is reached in the world of asintya, or no thought, where all the unity of all opposites becomes a vivid experience. In the words of a Zen poem, "At dusk the cock announces down, at midnight the bright sun." The notion that all opposites are polar, that light and dark, winning and losing, good and evil, are merely different aspects of the same phenomenon, is one of the basic principles of the Eastern way of life. Since all opposites are interdependent, their conflict can never result in the total victory of one side, but will always be a manifestation of the interplay between the two sides. In the East, a virtuous person is therefore not one who undertakes the impossible task of striving for the good and eliminating the bad, but rather one who is able to maintain a dynamic balance between good and bad. This notion of dynamic balance is essential to the way in which the unity of opposites is experienced in Eastern mysticism. It is never a static identity, but always a dynamic interplay between two extremes. This point has been emphasized most extensively by the Chinese sages in their symbolism of the archetypal poles yin and yang. They call the unity lying behind yin and yang the Tao, and saw it as a process which brings about their interplay. That which lets now the dark, now the light appears as Tao. The dynamic unity of polar opposites can be illustrated with the simple example of a circular motion and its projection. Suppose you have a ball going around a circle. If this movement is projected onto a screen, it becomes an oscillation between two extreme points. To keep the analogy with the Chinese thought, I've written Tao in a circle and marked it with extreme points, blah, blah, blah. It's this diagram. The ball goes around the circle and with constant speed, but in the projection, it slows down as it reaches the edge, turns around, and then accelerates again, only to slow down once more. And so on, in endless cycles. In any projection of that kind, the circular movement will appear as an oscillation between two opposite points. But in the movement itself, the opposites are unified and transcended. This image of a dynamic unification of opposites was indeed very much in the minds of the Chinese thinkers, as can be seen from the passage in the Shuangzi quoted previously, that the that and the this cease to be opposites is the very essence of Tao. Only this essence, an axis, as it were, is the center of the circle responding to the endless changes. One of the principal polarities in life is the one between the male and female sides of human nature. As with the polarity of good and bad, or of life and death, we tend to feel uncomfortable with the male-female polarity in ourselves, and therefore we bring one or the other side into prominence. Western society has traditionally favored the male side rather than the female, instead of recognizing that the personality of each man and of each woman is the result of an interplay between female and male elements. It has established a static order, where all men are supposed to be masculine and all women feminine, and it has given men the leading roles in most of society's privileges. This attitude has resulted in an overemphasis of all the yang, or male aspects of human nature: activity, rational thinking, competition, aggressiveness, and so on. The yin, or female, modes of consciousness, which can be described by words like intuitive, religious, mystical, occult, or psychic, have constantly been suppressed in our male-oriented society. In Eastern mysticism, these female modes are developed, and a unity between the two aspects of human nature is sought. A fully realized human being is one who, in the words of Lao Tzu, knows the masculine and yet keeps to the feminine. In many Eastern traditions, the dynamic balance between the male and female modes of consciousness is the principal aim of meditation, and is often illustrated in works of art. A superb sculpture of Shiva in the Hindu temple of Elephanta shows three faces of the god. On the right, his male profile, displaying virility and willpower. On the left, his female aspect, gentle, charming, seductive. And in the center, the sublime union of the two aspects in the magnificent head of Shiva Mahasavara, the great lord, radiating serene tranquility and transcendental aloofness. In the same temple, Shiva is also represented in androgynous form, half male, half female. the flowing movement of the god's body, and the serene detachment of his/her face, symbolizing, again, the dynamic unification of the male and female. In Tantric Buddhism, the male-female polarity is often illustrated with the help of sexual symbols. Intuitive wisdom is seen as the passive female quality of human nature, love and compassion as the active male quality, and the union of both in the process of enlightenment is represented by ecstatic sexual embraces of male and female deities. The Eastern mystics affirm that such a union of one's male and female modes can be experienced only on a higher plane of consciousness, where the realm of thought and language is transcended and all opposites appear as a dynamic unity. I've already asserted that a similar plane has been reached in modern physics. The exploration of the subatomic world has revealed a reality which repeatedly transcends language and reasoning, and the unification of concepts, which had hitherto seemed opposite and irreconcilable, turns out to be one of the most startling features of this new reality. These seemingly irreconcilable concepts are generally not the ones the Eastern mystics are concerned with, although sometimes they are, but their unification at a non-ordinary level of reality provides a parallel to Eastern mysticism. Modern physicists should therefore be able to gain insights into some of the central teachings of the Far East by relating them to experiences in their own field. A small but growing number of young physicists have indeed found this a most valuable and stimulating approach to Eastern mysticism. Examples of the unification of opposite concepts in modern physics can be found at the subatomic level, where particles are both destructible and indestructible, where matter is both continuous and discontinuous, and force and matter are but different aspects of the same phenomenon. In all these examples, which will be discussed extensively in subsequent chapters, it turns out that the framework of opposite concepts, now derived from our everyday experience, is too narrow for the world of subatomic particles. Relativity theory is crucial for the description of the world, and in the relativistic framework, the classical concepts are transcended by going to a higher dimension, the four-dimensional space-time. Space and time themselves are two concepts which had seemed entirely different, but have been unified in relativistic physics. This fundamental unity is the basis of the unification of the opposite concepts mentioned above. Like the unity of opposites experienced by the mystics, it takes place on a quote-unquote higher plane and a higher dimension, and like that experienced by the mystics, it is a dynamic unity, because the relativistic space-time reality is an intrinsically dynamic reality, where objects are also processes and all forms are dynamic patterns. To experience the unification of seemingly separate entities in a higher dimension, we do not need relativity theory. It can also be experienced by going from 1 to 2 dimensions, or from 2 to 3. In the example of circular motion and its projection given on page 132 of the blah, 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 opposite poles of the oscillation in one dimension along a line are unified in the circular movement in 2 dimensions in one plane. The drawing you can't see below represents another example involving a transition from 2 or 3 dimensions. It shows a donut ring cut horizontally by a plane. In the 2 dimensions of that plane, the surfaces of the cut appear as 2 completely separate disks. But in 3 dimensions, they are recognized as being parts of one and the same object. A similar unification of entities, which seem separate and irreconcilable, is achieved in relativity theory by going from 3 to 4 dimensions. The 4-dimensional world of relativistic physics is the world where force and matter are unified, where matter can appear as discontinuous particles or as a continuous field. In these cases, however, we no longer visualize the unity very well. Physicists can experience the 4-dimensional space-time world through the abstract mathematical formulation of their theories, but their visual imagination, just like everybody else's, is limited to the 3-dimensional world of the senses. Our language and thought patterns have evolved in this 3-dimensional world, and therefore we find it extremely hard to deal with the 4-dimensional reality of relativistic physics. Eastern mystics, on the other hand, seem to be able to experience a higher dimensional reality directly and concretely. In the state of deep meditation, they can transcend the 3-dimensional world of everyday life and experience a totally different reality where all opposites are unified into an organic whole. When the mystics try to express this experience in words, they are faced with the same problems as the physicists trying to interpret the multidimensional reality of relativistic physics. In the words of Lama Govinda, An experience of higher dimensionality is achieved by integration of experiences of different centers and levels of consciousness. Hence, the indescribability of certain experiences of meditation on the plane of three-dimensional consciousness and within a system of logic, which reduces the possibilities of expression by imposing further limits upon the process of thinking. The four-dimensional world of relativity theory is not the only example in modern physics where seemingly contradictory and irreconcilable concepts are seen to be nothing more than different aspects of the same reality. Perhaps the most famous case of such a unification of contradictory concepts is that of the concepts of particles and waves in atomic physics. At the atomic level, matter has a dual aspect. It appears as particles and as waves. Which aspect it shows depends on the situation. In some situations, the particle aspect is dominant. In others, the particles behave more like waves. And this dual nature is also exhibited by light and all other electromagnetic radiation. Light, for example, is emitted and absorbed in the form of quanta, or photons. But when these particles of light travel through space, they appear as vibrating electric and magnetic fields, which show all the characteristic behavior of waves. Electrons are normally considered to be particles, and yet when a beam of these particles is sent through a small slit, it is diffracted just like a beam of light. In other words, electrons too behave like waves. This dual aspect of matter and radiation is indeed most startling and gave rise to many of the quantum cones, which led to the formulation of quantum theory. The picture of a wave which is always spread out in space is fundamentally different from the particle picture, which implies a sharp location. It has taken physicists a long time to accept the fact that matter manifests itself in ways which seem to be mutually exclusive. That particles are also waves, waves also particles. Looking at the two pictures, a layperson might be tempted to think that the contradiction can be resolved by saying that the picture on the right-hand side simply represents a particle moving in a wave pattern. This argument, however, rests on a misunderstanding of the nature of waves. Particles moving in wave patterns do not exist in nature. In a water wave, for example, the water particles do not move along with the wave, but move in circles as the wave passes by. Similarly, the air particles in a sound wave merely oscillate back and forth, but do not propagate along with the wave. What is transported along the wave is the disturbance causing the wave phenomenon, but not any material particle. In quantum theory, therefore, we do not speak about a particle's trajectory when we say that the particle is also a wave. What we mean is that the wave pattern as a whole is a manifestation of the particle. The picture of traveling waves is thus totally different from that of traveling particles, as different, in the words of Victor Weisskopf, quote-unquote, as the notion of waves on a lake from that of a school of fish swimming in the same direction. The phenomenon of waves is encountered in many different contexts throughout physics and can be described with the same mathematical formalism whenever it occurs. The same mathematical forms are used to describe a light wave, a vibrating guitar string, a sound wave, or a water wave. In quantum theory, these forms are used again to describe the waves associated with particles. This time, however, the waves are much more abstract. They are closely related to the statistical nature of quantum theory, to the fact that atomic phenomena can only be described in terms of probabilities. The information about the probabilities for a particle is contained in a quantity called the probability function, and the mathematical form of this quantity is that of a wave. That is to say, it is similar to the forms used for the description of other types of waves. The waves associated with particles, however, are not real three-dimensional waves, like water waves or sound waves, but are probability waves, abstract mathematical quantities which are related to the probabilities of finding the particles in various places and with various properties. The introduction of probability waves, in a sense, resolves the paradox of particles being waves by putting it in a totally new context. But at the same time, it leads to another pair of opposite concepts, which is even more fundamental, that of existence and non-existence. This pair of opposites, too, is transcended by the atomic reality. We can never say that an atomic particle exists at a certain place, nor can we say that it does not exist. Being a probability pattern, the particle has tendencies to exist in various places and thus manifests a strange kind of physical reality between existence and non-existence. We cannot therefore describe the state of the particle in terms of fixed opposite concepts. The particle is not present at a definite place, nor is it absent. It does not change its position, nor does it remain at rest. What changes is the probability pattern, and thus the tendencies of the particle to exist in certain places. In the words of Robert Oppenheimer, if we ask, for instance, whether the position of the electron remains the same, we must say no. If we ask whether the electron's position changes with time, we must say no. If we ask whether the electron is at rest, we must say no. If we ask whether it is in motion, we must say no. The reality of the atomic physicist, like the reality of the Eastern mystic, transcends the narrow framework of opposite concepts. Oppenheimer's words thus seem to echo the words of the Upanishads. It moves not. It is far and it is near. It is within all this, and it is outside all this. Force and matter, particles and waves, motion and rest, existence and non-existence. These are some of the opposite or contradictory concepts which are transcended in modern physics. Of all the opposite pairs, the last seem to be the most fundamental. And yet, in atomic physics, we have to go even beyond the concepts of existence and non-existence. This is the feature of quantum theory, which is most difficult to accept and which lies at the heart of the continuing discussion about its interpretation. At the same time, the transcending of the concepts of existence and non-existence is also one of the most puzzling aspects of Eastern mysticism. Like the atomic physicists, the Eastern mystics deal with a reality which lies beyond existence and non-existence, and they frequently emphasize this important fact. Thus, Ashvagosha, quote, suchness is neither that which is existence, nor that which is non-existence, nor that which is at once existence and non-existence, nor that which is not at once existence and non-existence. Faced with a reality which lies beyond opposite concepts, physicists and mystics have to adopt a special way of thinking where the mind is not fixed in the rigid framework of classical thought or logic, but keeps moving and changing its viewpoint. In atomic physics, for example, we are now used to applying both the particle and the wave concept in our description of matter. We have learned how to play with the two pictures, switching from one to the other and back in order to cope with the atomic reality. This is precisely the way in which the Eastern mystics think when they try to interpret their experience of a reality beyond opposites. In the words of Lama Govinda, the Eastern way of thinking rather consists in a circle rounding the object of contemplation, a many-sided, i.e. multi-dimensional impression formed from the superimposition of single impressions from different points of view. To see how one can switch back and forth between the particle picture and the wave picture in atomic physics, let us examine the concepts of waves and particles in more detail. A wave is a vibrational pattern in space and time. We can look at it at a definite instant of time and then see a periodic pattern in space, as in the following example, which looks like the sound wave. This pattern is characterized by an amplitude A, the extension of the vibration, and a wavelength L, the distance between the two successive crests. Alternatively, we can look at the motion of a definite point of the wave and will then see an oscillation characterized by a certain frequency, the number of times the point oscillates back and forth every second. Now let us turn to the particle picture. According to classical ideas, a particle has a well-defined position at any time, and its state of motion can be described in terms of its velocity and its energy of motion. Particles moving with a high velocity also have a high energy. Physicists, in fact, hardly use quote-unquote velocity to describe the particle's state of motion, but rather use a quantity called momentum, which is defined as the particle's mass times its velocity. Quantum theory now associates the properties of a probability wave with the properties of the corresponding particle by relating the amplitude of the wave at a certain place to the probability of finding the particle at that place. Where the amplitude is large, we are likely to find the particle if we look for it. Where it is small, unlikely. The wave train, blah, 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 for example, has the same amplitude throughout its length, and the particle can therefore be found anywhere along the wave with the same likelihood. The information about the particle's state of motion is contained in the wavelength and frequency of the wave. The wavelength is inversely proportional to the momentum of the particle, which means that a wave with a small wavelength corresponds to a particle moving with a high momentum, and thus with a high velocity. The frequency of the wave is proportional to the particle's energy. A wave with a high frequency means that the particle has a high energy. In the case of light, for example, violet light has a high frequency and a short wavelength, and consists therefore of photons of high energy and high momentum, whereas red light has a low frequency and a long wavelength, corresponding to photons of lower energy and momentum. A wave which is spread out like the one in the example here does not tell us much about the position of the corresponding particle. It can be found anywhere along the wave with the same likelihood. Very often, however, we deal with situations where the particle's position is known to some extent, as for example in the description of an electron in an atom. In such a case, the probabilities of finding the particle in various places must be confined to a certain region. Outside this region, they must be zero. This can be achieved by a wave pattern, just like the one which corresponds blah, 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 blah. You can't see it, so we'll move on that. It is composed of several waves, blah, blah, blah. Such a pattern is called a wave packet. It is composed of several wave trains and various wavelengths which interfere with each other destructively outside the region X, so that the total amplitude, and thus the probability of finding the particle there, is zero, whereas they build up the pattern inside X. The pattern shows that the particle is located somewhere inside the region X, but it does not allow us to localize it any further. For points inside the region, we can only give the probabilities for the presence of the particle. The particle is most likely to be present in the center, where the probability amplitudes are large, and less likely near the ends of the wave packet, where the amplitudes are small. The length of the wave packet represents, therefore, the uncertainty in the location of the particle. The important property of such a wave packet now is that it has no definitive wavelength. The distances between two successive crests are not equal throughout the pattern. There is a spread in wavelength, the amount of which depends on the length of the wave packet. The shorter the wave packet, the larger the spread in wavelength. This has nothing to do with quantum theory, but simply follows from the properties of waves. Wave packets do not have a definite wavelength. Quantum theory comes into play when we associate the wavelength with the momentum of the corresponding particle. If the wave packet does not have a well-defined wavelength, the particle does not have a well-defined momentum. This means that there is not only an uncertainty in the particle's position, corresponding to the length of the wave packet, but also an uncertainty in its momentum, caused by the spread in its wavelength. The two uncertainties are interrelated because the spread in wavelength, i.e. the uncertainty of momentum, depends on the length of the wave packet, i.e. the uncertainty of position. If we want to localize the particle more precisely, that is, if we want to confine its wave packet to a smaller region, this will result in an increase in the spread in wavelength and thus in an increase in the uncertainty of the particle's momentum. The precise mathematical form of this relation between the uncertainties of position and momentum of a particle is known as Heisenberg's uncertainty relation, or uncertainty principle. It means that in the subatomic world, we can never know both the position and momentum of a particle with great accuracy. The better we know the position, the hazier will its momentum be, and vice versa. We can decide to undertake a precise measurement of either of the two quantities, but then we will have to remain completely ignorant about the other one. It is important to realize, as we pointed out in the previous chapter, that this limitation is not caused by the imperfection of our measuring techniques, but it is a limitation of principle. If we decide to measure the particle's position precisely, the particle simply does not have a well-defined momentum and vice versa. The relation between the uncertainties of a particle's position and momentum is not the only form of this uncertainty principle. Similar relations hold between other quantities, for example, between the time an atomic event takes and the energy it involves. This can be seen quite easily by picturing our wave packet not as a pattern in space, but as a vibrational pattern in time. As the particle passes a particular point of observation, the vibrations of the wave pattern at that point will start with a small amplitudes, which will increase and then decrease again until finally the vibration will stop altogether. The time it takes to go through this pattern represents the time during which the particle passes our point of observation. We can say that the passage occurs within this time span, but we cannot localize it any further. The duration of the vibration pattern represents, therefore, the uncertainty in the temporal location of the event. Now, as the spatial pattern of the wave packet does not have a well-defined wavelength, the corresponding vibrational pattern in time does not have a well-defined frequency. The spread in frequency depends on the duration of the vibrational pattern, and since quantum theory associates the frequency of the wave with the energy of the particle, the spread in the pattern's frequency corresponds to an uncertainty in the particle's energy. The uncertainty in the location of an event in time thus becomes related to an uncertainty in energy in the same way as the uncertainty of a particle's location in space is related to an uncertainty in momentum. This means that we can never know both the time at which an event occurs and the energy involved in it with great accuracy. Events occurring inside a short time span involve a large uncertainty in energy. Events involving a precise amount of energy can be localized only within a long period of time. The fundamental importance of this uncertainty principle is that it expresses the limitations of our classical concepts in a precise mathematical form. As described previously, the subatomic world appears as a web of relations between the various parts of a unified whole. Our classical notions derived from our ordinary macroscopic experience are not fully adequate to describe this world. To begin with, the concept of a distinct physical entity like a particle is an idealization which has no fundamental significance. It can only be defined in terms of its connections to the whole, and these connections are of a statistical nature, probabilities rather than certainties. When we describe the properties of such an entity in terms of classical concepts, like position, energy, momentum, we find that there are pairs of concepts which are interrelated and cannot be defined simultaneously in a precise way. The more we impose one concept on the physical object, the more the other concept becomes uncertain, and the precise relation between the two is given by the uncertainty principle. For a better understanding of this relation between pairs of classical concepts, Niels Bohr has introduced the notion of complementarity. He considered the particle picture and the wave picture as two complementary descriptions of the same reality, each of them being only partly correct and having a limited range of application. Each picture is needed to give a full description of the atomic reality, and both are to be applied within the limitations given by the uncertainty principle. This notion of complementarity has become an essential part of the way physicists think about nature, and Bohr has often suggested that it might be a useful concept also outside the field of physics. In fact, the notion of complementarity proved to be an extremely useful 2,500 years ago. It played an essential role in ancient Chinese thought, which was based on the insight that opposite concepts stand in a polar or complementary relationship to each other. The Chinese sages represented this complementarity of opposites, be the archetypal poles yin and yang, and saw their dynamic interplay as the essence of all natural phenomenon and all human situations. Niels Bohr was well aware of the parallel between his concept of complementarity and Chinese thought. When he visited China in 1937, at a time when his interpretation of quantum theory had already been fully elaborated, he was deeply impressed by the ancient Chinese notion of polar opposites, and from that time he maintained an interest in Eastern culture. 10 years later, Bohr was knighted as an acknowledgement of his outstanding achievements in science and important contributions to Danish cultural life. And when he had to choose a suitable motif for his coat of arms, his choice fell on the Chinese symbol of Tai Chi, representing the complementary relationship of the archetypal opposites yin and yang. In choosing this symbol for his coat of arms together with the inscription Contraria sunt complementa, opposites are complementary, Niels Bohr acknowledged the profound harmony between ancient Eastern wisdom and modern Western science. So there's your lesson for today. Ladies, gentlemen, it's they, them, whatever your pronoun, whatever it is, we respect it here at the Dr. Zero Free Magic Secret Show. So hit the subscribe button. Please post these videos on Facebook and Twitter and anywhere else, TikTok, whatever you got. Let people know I exist. If you're enjoying this, just keep it cranking out, because the magic is free. Free magic for all. Spread the magic. It's free to spread the magic. All you do is copy, paste. Go, yo, look at this. It's a giant flag. Not a red flag is something bad. Not a white flag is surrender, but a new flag. But a flag of donation, a flag of you, a flag of the spirit. That's it. No, it's not a flag. It's a lantern. This is a lighthouse. This show's a lighthouse. This show's a lighthouse, trying to bring everybody in. But we're not saying you can't think dark things. We're not saying we don't examine the dark. We're just saying come over here, come over here, come over here, come to the seashore. We can turn off the light if you want. We'll just hang out and smell the ocean. Sperm whales. They're creepy. They're really big. Creepy, creepy, creepy. Anyway, see you later, folks.
Mortal combat begins.
A handful of people on a leaky boat are gonna save the world.
Exactly. Enough!